Where does this belief come from? Yet another website about training people. Here we can see someone who's about to be trained to use the right-hand side of their brain. And I'm going to highlight an area of this slide here. The right brain concept first began to attract widespread interest when Dr. Roger Sperry of the California Institute of Technology won a Nobel Prize for his work on the functions of the brain's hemispheres. And since then, the concept has been utilized in areas as diverse as education, business, and medicine. Well, we've seen some of those uses there. And this is all true. This is the origin of the idea, the recognition that the two hemispheres of our brains have distinctly different, maybe identifiable functions. And Roger Sperry did win a Nobel Prize for this work. But he didn't win the prize for saying the right brain's creative and the left brain is logical. He won his Nobel Prize, really, for work on epileptics. Because in the 1960s, not a lot was known about how epilepsy worked. What was known was that epilepsy seemed to be related to sort of random firing neural activity happening in the brain. That you'd have a focus that would trigger, one part of the brain would suddenly become very active and basically fire randomly, noisily. And this activation would spread throughout the whole brain and cause an epileptic fit. And it could be controlled with drugs in most people, but in some people it couldn't. In some people, they were so disabled by frequent, several times an hour epileptic fits that they were really sort of hospitalized, they couldn't do anything. So in an experimental set of studies, given that these people were so severely disabled and couldn't be helped by drugs, they actually undertook some brain surgery on them. And as we've seen, you have two hemispheres in your brain, and I've stressed that they are not separate. They are connected, as you see here in this small box on the big picture of the brain is enlarged here, where it says Corpus Callosum. They are connected by a tight bundle of fibres that link these two hemispheres. So if you think of a walnut, when you crack open a walnut, if you're very good, you can actually get the whole walnut out of the shell. There's a little bit of walnut that joins the two together. The brain's the same, although you tend not to try to break the skull open. And the corpus callosum sends messages between the two hemispheres. It allows them to communicate. And what Sperry and his colleagues wondered was that, okay, well, if we actually sever the corpus callosum, so you have got two distinct hemispheres that cannot communicate, then if the focus in one hemisphere starts to activate randomly, it will cause neural paralysis in that hemisphere, but it can't spread over to the other one, so you won't get a total fit. What would happen to these severely disabled people if they did that? That was the operation. It was called a commissurotomy because you're cutting this commissure, the join between the two halves of the brain. That's what led to him receiving the Nobel Prize in 1981, because it did cure these epileptics. It made them much more able to function in the world. But there are some side effects of having the corpus callosum cut. And one of them that's very interesting and allows us to do allowed Sperry and his colleagues to do some very interesting experiments, is based on the way our visual system works. So here I've got a schematic of two eyes, which are the things with the white lenses at the front, and the visual cortices in the brain. Now those are at the back of the head, and I've coloured one yellow and one red. And the long horizontal line that's red and yellow at the front represents everything that you can see. So imagine that I'm standing here and this half of the lecture theatre is coloured red and that half of the lecture theatre is coloured yellow. Now, if you're just looking straight at the middle of the slide, obviously both eyes are seeing everything. So on the retinas of these eyes, I'm showing a yellow bit and a red bit. And the first thing to notice is that our lenses in our eyes turn everything back to front. So you've got the yellow bit that's on that side of the lecture theatre actually falls on the other side of your retina. And the red bit goes on this side. So that's the first thing to notice. Okay, so both eyes see the whole visual field. But after that, each half of the retina goes to one visual cortex. So the right-hand half of each retina, that's seeing the left side of the world, goes to the right visual cortex. And the left half of each retina, that's seeing the right-hand side of the world, goes to the left visual cortex. So each half of the visual cortex is seeing the opposite side of the world. So the left visual field projects to the right hemisphere, and the right visual field projects to the left hemisphere. Now, that means that this side of your head is seeing that side of the world, this side of your head is seeing that side of the world. So if you take a participant, here's our participant at the bottom, and you put them at the front of a table, and it's got a screen up there, and you say, now look at that red dot, and you flash up 2 words while they're looking at that red dot. Everything that's on the left-hand side of the screen gets processed by the right-hand side of their brain. So you can see that picture of the telephone has been represented in their right hemisphere, and the word dog has been represented in the left hemisphere. Now, normally, we move our eyes around, so both of these stimuli would get into both hemispheres. This only works if you stare at the dot and flash the stimuli up and take them away again. So Sperry and his colleagues were able to use experiments like this to test out what happened when you cut the communication between the brain. So people who have had their brains split by this commissurotomy, they found out that if you had all these objects hidden under a cloth on the table or under a platform, that people could locate the objects that they were supposed to be looking for with their left hand, but not with their right hand, if the visual information is presented from the left visual field to the right hemisphere. So their right brain knows about it, they can find the object with their left hand. And information that was presented in the right visual field, which goes to the left side of the brain, also allowed their patients to name or describe what they could see. So they could read the word dog. If it's a picture of a dog, they could say, it's a dog. Only if it was on the right could they speak, not if it was on the left.